This is our first lesson for Unit 4, and the focus is going to be vocabulary and the location of special points on our graphs. For our vocabulary, our words, and you can find these on your first page of notes for 4.1, is monomial, degree, polynomial, standard form, and lead coefficient. Some of these terms will be familiar to you from earlier in the year and also from Algebra 1. But a monomial is basically a real number, a variable, or a product of a real number and one or more variables with whole number exponents. So a couple of things I want you to notice here is that we're talking about whole number exponents here and real numbers, so no imaginary. Okay, as far as degrees go, the degree is simply the power of the variable for the monomial. So if you had 5x to the fourth, 4 is the degree. And a polynomial is a monomial or several monomials that are all added together or subtracted. And the degree of the polynomial is the largest exponent among its monomial terms. Now also in your notes you'll see that it says what is a polynomial. And to be a polynomial, the power of each variable must be a whole number and the coefficients of each term must be a real number. So this kind of goes back up to what we were talking about monomials. So what that's telling me is 2i x to the fourth would plus 8x squared would not be a polynomial because of the imaginary term here. When something's in standard form, when a polynomial is in standard form, it arranges the monomials in decreasing order. So the most familiar one that you have right now, we've been using the standard form, is the standard form of a quadratic, which looks like this. And then probably the newest term will be lead coefficient, and the lead coefficient is simply the lead term of a polynomial in standard form, and you're looking at that lead number. So if you had this string of numbers, like look at these over here to the left, to the right, the term with the highest degree is 6, so I know it would be first if I was writing this in standard form. So because this one's first, I know this is my lead coefficient. And this polynomial, it's already in standard form because the 3 and then 2 and then 1, so 5 would be the lead coefficient. And you can just abbreviate that with LC. All right, let's start at the top. What's the degree of this polynomial? The degree would be 3. Cross out any expressions that are not polynomials. The only one that is not a polynomial is this one, and that's because of the 1/2 and the -1. These in standard form, this one's going to be first, so it's going to be -5x to the 7th, and then plus 7x cubed plus 2x squared. And the second one, positive, excuse me. Okay, classifying polynomials is also important just so that we all are using the same terminology. This first one, you might want to try fill this in and then look at the answers. This is a constant. And an example of this might be something like y equals 7. This one is linear. And an example might be y equals 3x plus 2. Quadratic. This one, the highest degree is the 3, so it is a cubic. And these two are your new ones, cubic, and this one is a quartic. And in your book, it refers to these as simply fourth degree polynomials. Okay, another thing that you're going to be finding are the relative maximums and minimums of graphs. So if you look at this, I'm just going to kind of make this be this ocean floor. I'm just going to try to follow it like it's a graph. So you can kind of get this as in your mind as a little picture. If you look on the far left, it looks like this is flat. So it looks like this is a constant. But then gradually it's continuing to go down, down, down. But then it's rising again. It starts going up. There's a peak here, and then it's falling. It goes all the way down here, and then it's rising again. So if we're talking about a maximum, we're looking at the highest point in the general area. So right here would be a relative maximum, or it's also called a local max. And down here would be a local or relative minimum. If you'll notice that if you're at a maximum, then everything on the left of it is going down, everything to the right of it is going down, and this is the highest point. And just the opposite is true with the minimum. Every point, every y value, if you were looking at a graph, is going up. Okay, so take a minute, and on your second page of notes for this section, you should be able to draw and identify each one of these terms. So pause it and then try and then check your work. The end behavior is indicated by which direction the ends of the graphs are going. In this case, the left side is going to negative infinity and the right side is going to positive infinity.